Hello, everyone. My name is Jainschigg. I work for Mirantis, and I am here this afternoon, very gratefully, with Anders Wallgren, who is VP of Technology Strategy for CloudBees, a Mirantis partner, and a well-known company in the space that we're going to be discussing. Anders is also a well-known entity in this space, which is continuous integration and continuous delivery. You've seen already today some sessions that focus on specific implementations of continuous integration and delivery, particularly around security. And we think this is a critically important topic for anyone in the cloud space, particularly in this increasingly complicated Kubernetes space, to understand. Mirantis thinks, if I can recapitulate our own strategy and language, that with complexity and uncertainty consistently increasing, with the depth of the technology stacks that we have to deal with consistently elaborating themselves, that navigating this requires first the implementation of automation to increase speed, which is what CI and CD do, and that this speed be leveraged to let us ship and iterate code faster, since that's ultimately the business that all of us are in, one way or another. I would like, I guess, to open this conversation by asking Anders, what does he think of that core strategy?
I think, hitting the security thing right off the bat, security doesn't happen by accident. Security is not something that, like a server in a restaurant, sprinkles a little bit of Parmesan cheese right before they serve you the food. It's not something you sprinkle on at the end. It's something that has to be baked in from the beginning, not just in the kitchen, but in the supply chain from the very beginning. So it's a feature, and if you don't build it, you're not going to get an outcome that you're not going to be happy with. And I think and it's obviously increasingly important and increasingly visible. The kinds of security problems that we see these days can be life altering for people that are subject to them, and can be life or death for a company that's exposed to it. So it's very, very important to pay attention to it and to work to achieve that as an explicit outcome of the software delivery process. And I think CI and CD as process, as tooling, as culture plays a big part in that, because a lot of it has to do with set things up right. Run them the same way over and over. Get the machine going, turn the crank. Now you want to make improvements over time. It's not just set it and forget it. Oh, we got that set up, we don't have to worry about it anymore. But it really is a question of get the human out of the loop a lot of the times, because if you're dealing with configuring complex systems, you want to make sure that you get them set up, configured, documented, ideally, as code, whether it's a domain-specific language or something like that, and then that's something that you can test against, that you can verify against, that you can diff against, and then that becomes the basis for your software pipelines, for your automation around kind of the software factory floor. So I think automation is a key aspect of that, because it takes a lot of the drudgery out of it, for one thing. So now the humans have more time to spend on doing on the creative things. On the things that we're good at as humans. And it also makes sure that, one of the things that computers are really good at is doing the same thing over and over and over and over. So that kind of puts that responsibility into the hands of the entity that knows how to do that well, which is the machine. So I think it's it's a lot. It's a deep topic, obviously, but automation plays into it. Small batch sizes play into it. Being able to test very frequently. Whether that's testing in your CI pipeline, where you're sort of doing build and mostly unit testing, maybe some integration testing, but also in layering in the more serious kinds of testing in terms of security scanning, penetration testing, vulnerability scanning, those sorts of things, which maybe you do on every single CI build, but most people don't, because those things tend to take a little bit longer. And you want your CI cycle to be as fast as possible, because that's really in service of the developer who has committed code and wants to, kind of see the thumbs up from the system saying, yeah,
Sure.
you didn't do anything. So most,
Yeah,
most organizations, yeah,
in
most
one sense.
organizations are focusing on, making sure that there's a follow-on pipeline, a follow-on set of tests that happen after the CI passes successfully, and that's where a lot of the security scanning and those sorts of things happen.
It's an interesting problem. I mean, you mentioned what almost sounds like a Lawrence Lessig kind of idea that code is law. In enterprises today, code, particularly CI code, ends up being policy. But at the same time, it seems to me there's an alternative peril, which is as you increase speed, particularly when you become more and more dependent on things like containers and layering technology, to provide components and capabilities that you don't have to build yourself to your build pipeline, that there are new vulnerabilities potentially that creep in and can creep in despite automations, or at least first order automations attempts to prevent them from creeping in. You don't want to freeze people on a 6-month-old version of a key container image, but on the other hand, if the latest version has vulnerabilities, that could be a problem.
Yeah, I mean, it's a double-edged sword. It's two sides of the same coin. I think when I talk to a lot of security people, people who do it for a living, as opposed to me, I just talk about it. That's not completely true, but a lot of times the problem is old vulnerabilities. The thing that I think keeps a lot of people up at night isn't necessarily that the thing at the tip of the releases for a particular, well-known open source library or something like that, that's going to burn you. The vast majority of the time, and I want to say like 85% of the time, the vulnerabilities that you get hosed by are ones that have been known about for years. And so I think if I had to pick, so if in that sort of two sides of that coin, if I had to pick, I would say be aggressive in making sure that your third-party dependencies are updated frequently and continuously, right? Because that is the biggest cause of security vulnerabilities when it comes to third-party code. Now, the famous saying, move fast and break things. Well, there are certain things you don't want to break. You don't want to break a radiation machine that's going to deliver radiotherapy to someone because that will endanger their health. So those sorts of systems naturally are subject to a little bit more kind of caution and scrutiny and rigor and process, those sorts of things. The microservice that I run that shows my little avatar when I log in, that one probably gets a little less scrutiny, and rightfully so. So I think a lot of it has to do, and somebody once said in a I think it was a panel I was on at the RSA conference, which was a kind of a wise thing to say, was don't spend $1 million protecting a $5 asset. You want to be smart, and you want to figure out where your vulnerabilities are going to come from. And in my experience, and what I hear from a lot of the security professionals is pay attention to your supply chain. You want to make sure that you're up to date with the latest patches of all of your third-party, open source or closed source. It doesn't really matter. I mean, if anything, open source is more open, so you can inspect things a little bit better than with closed source. But with both kinds of streams of code that you consume and use, you want to make sure that you're more up to date as opposed to less up to date. That generally will be better. Now, can a new version of a library cause problems? Introduce bugs? Those sorts of things. Yes, that's why we have tests. That's why we have automated tests, regression suites. Those sorts of things. And so you want to live in a world where you feel the confidence as a developer that if I update this library from 1.0.3 to 1.0.10 to pick up a bunch of bug fixes and patches and those sorts of things, that's not going to break something. And the test suites that will run against that ought to cover that sort of functionality. And I'd rather be in that world of oh yeah, we tried to update to that, but it broke the tests, and then have to go spend time on that, than say, oh, it broke the test, so let's not update. And then 6 months later, you do find out, oh, geez, there was a problem in 1.0.3 and it was fixed in 1.0.4. If only we had updated. You look at you look at some of the highest profile security breaches that are out there that you sort of can trace to third-party libraries, it's almost always going to be that it was out of date and hadn't been patched. So that's my opinionated take on that.
Sure. What are the parts of modern CI/CD as opposed to what one would encounter 5-6 years ago, maybe, if we can imagine that as being before the microservices and containers revolution really took off?
I think you're absolutely right that not the whole world is not doing CI yet, and certainly the whole world is not doing CD yet. I think as you say, we kind of live in a little bit of an ivory tower. We live in an echo chamber and a little bit of a bubble as vendors in this space. The truth is that I would say less than 50% of the software organizations out there do real CI, do real CD. The number is probably less than that. I don't have anything to back that up other than just I talk to a lot of folks and work with with a lot of organizations, and I'm like, yeah, that team does CI, that team does weekly builds, those sorts of things. It's really all over the place, and a lot of times there's definitely in my experience a high correlation there with the amount of time that a team or a code base has been around and the amount of sort of modern technologies and processes and so on that are brought to it. And that sort of makes sense. I mean, if you're starting with a green field with a blank sheet of paper, you're going to adopt the technologies and the processes and the cultures of today, not of 5, 10, 15 years ago. But most organizations are moving in that direction, right? And I think what's really changed in the last few years is the level of integration between the various tools, between the various pieces, and the amount of automation that you can bring to bear. I mean, I remember 5 or 10 years ago having all kinds of conversations with customers and prospects and people at conferences and so on, and they said, oh yeah, we'd like to automate our software development lifecycle, but we can't. We have a manual thing here, we have a manual thing there, we do this kind of testing and we can't automate it, and then we have this system but it doesn't have an API, so somebody has to sit and click on the screen, and I used to say I don't accept no for an answer of can you automate this, right? Anything can be automated, even if you just get the little drinking bird, that just pokes the mouse every once in a while. you can automate it. And I actually, I had one customer who was like, okay, and we had a discussion, and they said, well, we have this old Windows tool. It's an obscure tool. It's no longer updated, but it's used in a critical part of the life cycle, and it can't be automated. And I said, well, just install one of those Windows tools that allows you to peek and poke at the mouse with
at the screen. And stuff. Right.
And I said, so I don't accept your answer. And they said, well, unfortunately, security won't allow us to install those tools. So I had to accept no at that point. But I think the big change, or one of the biggest changes that's happened in the last few years is the systems now have all have APIs, and they all talk to each other. So if you've got if you've got a scanning tool, if you've got a deployment tool, if you have a deployment infrastructure, Kubernetes based, or kind of sitting in front of or around Kubernetes, these things all talk to each other and are all automated. So one of the things that's happened is we've taken out a lot of the wait states, a lot of the pauses, right? So if you do something like a value stream mapping where you sit down, and I'll date myself here and probably lose some in the audience with this analogy, but if you remember Schoolhouse Rock, the cartoons in the late 70s, early 80s, sure. There was one which was one of my favorites, and the guy who did the music for this passed away last year, sadly, but it was called How a Bill Becomes a Law. And they personified the bill. So the bill, becomes a little person, and first I'm passed by the House, and then the Senate, and then the president either signs me or doesn't, or he vetoes, and it really sort of did this. And what I always talk about with respect to sort of value stream mapping and talking about your process is put a GoPro camera on your source code's head, and then follow that source code all the way through to your customer. Understand all of the stuff that happens to it, including nothing. Right? Because a lot of times in that elapsed time, nothing keeps happening, right? If we built software the way if we built cars the way we build software, we would install the radio in a car, and then we would park it in a corner of the factory for 3 weeks. And then we might remember to test the radio before we ship the car out to the customer. right? Because that's how a lot of us still develop software. And I think one thing that's changed in the last few years is that we don't have these kind of, well, we did the build, so now we're waiting for somebody to create an environment and rack up some hardware and install an operating system and install, this, that, and the other. That went from manual to we use Chef or Puppet to do it, which then went to we use containers to do it, which then went to we use containers and Kubernetes to do it. So whole swaths of elapsed time in our software development life cycles basically went to nothing, right? And went to the point where we can configure them way to the left and follow them all the way through, and that the artifact that we're delivering isn't necessarily an executable. It could be a container, right? So now that starts to get interesting for us in terms of being able to test against that container, scan against that container, diff against that container, and it does bring complexity too in terms of now you got a layered file system in there. Well, what all is in there? And so there's tools for scanning those kinds of things. But I think that one of the biggest things that's happened is a lot of the natural pause points are no longer natural pause points. They are unnatural pause points, and they're now just delays in your software delivery. And so what a lot of organizations are working on is kind of getting to the point where those sorts of things get automated and connected. And that's now possible, and it wasn't 5 or 10 years ago.
So it sounds like a great deal of the speed benefit, which has been quantified many different ways, but is, once you get one of these systems working, as we've all experienced, enormous, is actually done by collapsing out what would have been unused time in a prior process, or non-parallelizable stuff has been made parallel.
I remember spent some time with a customer, and they did a value stream mapping. And they found out at the end that of the 30 days of elapsed time, they were spending 3 days on task. Everything else was waiting for a build, waiting for an install, waiting for an environment, waiting for an approval, having meetings, those sorts of things. And I thought to myself, oh my goodness, 90% of the elapsed time is doing nothing. And I was talking to someone, Gene Kim actually, and I said, oh my God, it was terrible. These people are screwed. And he says, oh, 90%, that's actually pretty good. So I think, if you think today, if you look at the teams that are doing just real pure continuous delivery, write some code, commit it, gets picked up by the CI system, it passes through CI, it goes through whatever post-CI processing you need to do, security scanning and so on. It gets staged and it gets pushed into production. That stuff can happen in minutes, right? That's new, that's different. Now, if you do that without having the right automated gates in place around security and those sorts of things, then you're living a little bit dangerously. Although I would argue not necessarily any more dangerously than just letting that insecure code sit around for a week before you ship it, right? It's not like that problem's going to fix itself if you just let it sit there. But you definitely operate at a higher velocity. Now that's a lot of the benefit that you're trying to get out of it, right? You can get stuff out to the market faster, or if you take a little bit more time, you get more out to the market in the same amount of time. You can turn around and fix problems faster. If you have a vulnerability, you can get it fixed and pushed out much more quickly. If you have a competitive threat that you need to address, you can move that much faster. If you have a critical bug, all security issues are bugs, sort of by definition. But if you have a functionality bug, you can get that pushed out faster. So I think kind of all factors of the business benefit from this increase in speed, and I think developers do too, because anybody, any human that has to context switch and step away from something for a duration of time longer than a few minutes, you're going to flush
productivity. Yeah.
You're going to have to load back up again, and so that's productivity loss. Now that's a soft cost, but man, is it expensive and is it painful? So you see a lot of benefit there, I think.
If you have an organization that is just starting this journey, what would you ask that organization to consider in order to sort of move them down this path?
It's by far the most frequent and almost always the first question I get at the end of a talk or a presentation or something like that is, where do we start? How do I know where to start? And there's a couple of answers to that. One is don't boil the ocean, right? Don't try to fix everything all at once. That because that's not agile, right? Be agile about your transformation here. Pick a set of problems that you have and make a basically make a burn down list and do them in order. So find a pain point that you have, right? And just go address that and try to make it small and actionable, and especially early on when you're trying to affect change and you're trying to convince teams that this is the way to go. And you may have some naysayers, or you may have people who are skeptical or who have been through these processes before that have been failures, or at least not the successes that they were supposed to be. It's important to have some wins. So what I always say is, look, if you have a pebble in your shoe, you've got a pain point. You know how to address that. You're not going to address that by changing out your wardrobe or by buying a new pair of shoes. You're going to address that by taking your shoe off, shaking it until the pebble falls out, and then putting the shoe back on. So look for those kinds of use cases, right? So if your engineers are complaining that whenever I check in, the build is broken and we're not doing CI, well, then let's look at doing CI. Let's do CI, right? If you're not doing that, and for most organizations, setting up CI is a very manageable, very doable thing. There's lots of open source tooling out there. There's lots of commercial tooling out there to do that, to do it for small teams, to do it for large teams, and everything in between. If the problem is, gosh, every time we push a change, we break something. Or every time something works in staging, it doesn't work in production. Then you got to look at, well, how are these systems being configured? If you're configuring them manually, stop, automate the configuration of them. If you're fixing system manually, don't. As a friend of mine says, don't fix, repave. You don't want to. There's the story of how Google operates in their data centers. They don't go look for a broken disk drive and swap it out, when it breaks. They just have a team of people that, like, once a month or something, I don't know what the interval is, they just walk through the data center and they pull out all the dead stuff and they throw it out. And what they did was they assumed that at the scale that they operate, things are always going to break. Physical things are always going to break. You have to build the software to assume that breakage. And any system that assumes that we're going to step in when a disk drive is broken and fix it so that we can get back to running just isn't going to work at scale. There's a similarity, there's sort of a parallel to that in software, which is, anytime you have these kinds of complex systems, you have to assume that they're going to break. And you have to put the things in place to catch those things, the automated testing, whether it's, whether you have 10,000 tests that you've written already, or whether you have no tests and you just need to go write your first test. That journey, you've got to start somewhere. But my answer to the question is generally always just start small, pick a very specific problem, build a plan around it, build a burn down list of things that you want to address, and just start working your way down that the same way that you would for any, kind of agile project. Your transformation of your own processes, of your own internal systems, you should use agile processes for those as well, because if you go off for 6 months and build something, by the time you come back, it's going to be irrelevant probably to the problems that you were facing 6 months ago.
Then let's consider the situation of a company that's using CI and maybe CI and CD together, and they want to reach what you might call the next level. They've seen obvious benefits. They're interested in increasing their investment in and cycles devoted to this technology. You don't have to sell them anymore, but they're looking for a next direction. What would you say that direction should be?
I think oftentimes what organizations start to do is they start to look at feedback loops. So, and that starts to go into the area of sort of metrics and analytics and those sorts of things. We're always concerned about, we're always affected by things like, mean time to recovery, mean time to detection. What are our cycle times from, ideation to code commit? What's the cycle time from code commit to production? Those sorts of things. And you can't change what you don't measure. So a lot of times the next step after kind of getting the rudimentaries of CI or CD or some combination of both in place is start to measure stuff.
Measuring.
And then, but there I think, you got to be smart about it, because what you don't want to do is kind of just pull all the metrics out that exist, barf them up on a dashboard on a giant television screen and say, boom, metrics, right? Mic drop, go home. that's the wrong way to do it. You want to use metrics very specifically to achieve outcomes. So if you have an outcome that you want to achieve and you can tie it to a metric, start looking at that metric and start, working that problem. Once you've solved that problem, you can take that metric and if that's the metric you're showing on the big screen TV, you can pop that off and pick the next one and put it up there. I always worry when a little different when you're in a NOC or something like that, when you're looking at network stuff and so on. But I'm always leery of when I walk into a software development organization and you've got just a bazillion different metrics displayed all over the place, because they're not all relevant. They're not all relevant at the same time. Some of them you want to look at often. Some of them you just want to kind of set an alarm on and make sure that you don't go down in your basement every day to check that the sump pump is working. What you do is you put a little water detector in there and you have an alarm go off if the water level ever rises above a certain amount. Well, you want to do the same thing with metrics, right? Once you've gotten the water out of your basement, you don't have to go down there and look at it all the time. You put the little detector in and then you move on and you worry about something else. And so organizations, as they start to get a little bit more sophisticated, start to look at the analytics, the metrics, start to say, hey, look, if our cycle time from commit to deploy is this much and we want it to be this much, what happens during that time, and where can we take slices out of that, without affecting the outcomes in terms of quality and so on, or if it's from ideation to code commit, what can we do there? You start to do that, and then as you get those sort of virtuous cycles of feedback loops happening, you get better and better and better. But you want to be careful with metrics. You don't want to, like I said, you don't want to barf a bunch of metrics up just to say, look, we got metrics. Metrics are there to serve a particular outcome. And once you've achieved that outcome, and you know that you can continue to achieve that outcome, you turn it into an alarm or a trigger, and you put it out of sight. And you know that, you don't need to have like a code coverage metric prominently displayed. You pick a code coverage number that you're happy with, you work to achieve that. Once you achieve it, you just worry about not going below that threshold again. So you can take that graph off and just put a trigger on that says, if we ever get below this, raise an alarm or fail a build or fail a pipeline or something like that, and then start to focus on improving another metric or another outcome using another metric.
Makes enormous sense. So I'm afraid we are getting to be out of time. I want to thank you very much, Anders, for joining us today. This has been certainly informative for me, and I hope for the audience. Thank you very, very much for sharing your insight.